For this one, we've got a system of equations. We want to solve these two equations. So substitution or elimination is going to be our best bet. In this particular case, we don't have a variable by itself solved for, or we don't have a 1 coefficient for any of these variables, so it's not necessarily going to be easy to use substitution. So we're going to use elimination. And when you look at this, before you just put your head down and kind of grind through it, look at your system. So if I take this top equation and look at the relationship between it and the bottom equation, if I just take the top one and multiply it by 3, I get the bottom equation. And so that's a particular result for these. So let's go ahead and go through the math and kind of see what works out here. I'm going to multiply this. Remember, I need the same number with opposite signs in front of the variable. So if you look at the x, I've got to multiply the top one by 3 to get the same number, but I also need opposite signs. So I'm going to multiply that by a negative 3. We're going to rewrite our equation so that we have negative 15x minus 9y equals a negative 6. And then we're just going to bring our second equation over. So that's 15x plus 9y equals positive 6. And then we add our like terms. So our x's combined to give us a 0. Our y's combined to give us a 0. So 0 equals 0. And so in this particular case, because we basically got the same line, 0 equals 0 is a true statement. That means our graph is basically just one line being graphed. So if we go to graph that, it's going to look something like this. The y-intercept is going to be right around here. It's going to be a negative slope, negative 5 over 3. So it's going to go down a little bit more. So this is the graph of our first line. And if we graphed our second line, it would look exactly the same. So it would just overlap one another. In other words, where do these two lines intersect? Well, they intersect everywhere. So there are infinitely many solutions in this case. Or in other words, they intersect everywhere. Any point on this line is a solution to this system.